So what is an ingress? By the way, if you are able to hear me, please write something on the chat so I can continue for the topic. Yeah, okay. So let's continue then. An ingress is a set of rules to allow inbound connection to the access cluster services. As you may already remember from our previous webinars, that when you create something, some object within the Kubernetes cluster, by default, it is not accessible from the internet, right? This is the main security rule. But what about if you want to try to access these services from the outside? There are a couple of ways to do this. So you can create a service which has a type load balancer, or you can create a node port in order to access these services by using this port. But there is another way to do this. Let's see the advantages of Ingress on these cases. In order to create an Ingress resource, you need to have an Ingress controller to do that. Again, as you remember from the previous webinars, in order to create a resource, there were a couple of controllers in order to do this. For example, if you want to create a deployment, there is a deployment controller to do this kind of things. But this Ingress resource has a higher level abstraction, so this is controlled by another type of controller, which is called Ingress Controller. By the way, there are a couple of the Ingress Controller types, but Kubernetes by default supports GCE and then Nginx Controller in order to do that. But you can also use Traffic in order to make this Ingress thing work within your Kubernetes cluster. So Ingress Controller is not something that is managed by some controller like deployment controller. And then, but why do we need this stuff, this Ingress Controller? Why not we use a load balancer for each service? Okay, let's have a look at this in the example. Let's say that you have two services, service 1 and service 2. It has specific pods within this service. And then in order to expose this service to the outside, to the internet, you can use load balancer, for example. But if you are in a cloud platform like AWS, Google Cloud, and when you create load balancer per service, you will see that you will have lots of price at the end of the month. So instead of creating load balancer per service, you can create an ingress, and then there will be only here, load balancer will be high price, will have a high price, but in the Ingress type, you will have only one type of load balancer within your cloud platform, but the request will be in Ingress, specific Ingress after the load balancer. So you will have only one load balancer, and then Ingress controllers and Ingress resources will be responsible for routing traffic to a specific service, okay? As you can see, there is only one load balancer here. So this was very simple. You can think the ingresses like API gateways. So the traffic comes from the internet, and you can route the traffic into several services by using some rules, okay? We will see hands-on examples for this at the end of the session. So network policies. It is a specification to set up how a group of pods will be communicate each other or some external endpoints. So by default, when you create a service, the pods within that service will automatically will be able to connect each other. There will be no obligation, no restriction there. This is by default. But on some cases, you may want to restrict this way into several architectures. For example, let's say that you have you have DB instances per your application, and you can end up that, okay, I want to connect these DB instances by only the application, related application instances. So you can restrict this DB access in a way that only that specific application can access to this DB. So in order to do this, you need to enable something within your Kubernetes cluster, because by default, network policies will not work within your system because it has some cost. For example, it may need something like 300 millicores for the resource, and then it may need something like 128 megabyte for the in order to work in your system. So if you want to enable this one, you need to specify that explicitly. Okay, for example, if you are using Google Cloud Platform, you need to say that, okay, I want to enable this property after cluster setup. But in order to use these network policies, you need to use some network providers. From our very previous webinars, I have mentioned this topic, which is the network providers. In order to make your pod communicate each other, you need to use some kind of network provider, okay? So Calico, Cilium, Kubernetes, Romana, ViewNet, those are the network providers. In order to use network policies, you need to use one of these network providers within your cluster. In this session, we will use Calico in order to do this. By the way, while we are waiting this one, okay, we can continue, no problem. If I want to visualize this thing, for example, if you want to allow default Ingress connection to pod 2, that will be something like this, okay? Pod 1 can connect to pod 2, and also pod 3 can connect to pod 2. So, and also in the same way, pod 2 can connect to pod 1 and pod 3. Every pod can connect to each other. This is the Ingress allow default. We will use this example also. In some situations, for example, for the specific pod, you may need to deny all the Ingress connections here, and this is very simple, I think. Egress is the opposite of the Ingress. So Ingress is the internal connection to the internal one, and Egress for the outgoing connections. If you want to define some rules for the pod 2, you need to define egress, okay? So pod 2 can connect to pod 3 and pod 1. If you want to do this, you need to use egress rules to do that. What about the deny part? So you may need to have a rule in a way that pod 2 cannot connect to pod 3 and pod 1 by using some egress rules. So in some situation, you may say that, okay, pod 1 cannot connect to pod 2, but pod 3 can connect to pod 2. Then there will be something like this. For example, pod 2 can be a DB instance, and then pod 3 will be an application instance. So only pod 3 as an application instance will be able to connect to pod 2. But pod 1 may be something like another application instance. So there is no need to make this kind of communication between pod 1 and pod 2. In the same way, egress works like this. So pod 2 can have an outgoing connection to pod 3, but there will no connection from pod 2 to pod 1. Those are the theoretical information about the Ingress and the network policies. You may have a look at on the internet. You can search lots of things about network policies and Ingress, but this is a reference, okay? So we can continue with the workarounds. This is the power of our webinars. So first of all, I want to show you Ingress thing in order to show you how it is work. So I will start a minikube in order to show you Ingress rules. So here I am saying that, okay, start me an instance of Kubernetes cluster by using minikube, and the version will be 1.9.4. So by the way, the network policy part will be, I will show you the network policy part on the Google Cloud, Google Kubernetes engine, because you need to do some tricks in order to make network policies work here within the Minikube. As I said earlier, you need to use some certain network providers, but you need to do lots of things in order to make it work within here in Minikube. So here, let me here. I just wanted to delete those one. Let me do this. Minikube delete. I just wanted to make a fresh start. Okay. Even you are trying to use Ingress architecture here, you need to enable Ingress within the Minikube, and then you need to apply your Ingress rules within this Minikube cluster. By the way, during the startup, you can ask any kind of question. I can answer your questions during the cluster start. Okay, it is about to start. Okay, our cluster is ready. So when you do this Minikube add-ons list, you will see that the Ingress is enabled here. So there will be no problem with the Ingress. So we can continue how this Ingress works. When you say this one, I just wanted to be sure that, okay, Ingress Controller works correctly as expected. I need to see some pods related to Ingress here. Okay, as you can see here, Nginx Ingress Controller by default it works here. Okay, when you have a look at the logs, this is existing kube system, you will see that, okay, it is working as expected and successfully reloaded. Okay, I just wanted to add an example here. So what is our scenario here? I will create 3 APIs. Let's say that I will create 3 microservices, and then I will let the users make some requests into this microservice pool. Okay. My first microservice will be this one. By the way, in our previous webinars, we always use the declarative notation within the YAML files, but in order to make it quick, I will use the imperative one. So here I am saying that, okay, create a service here, run a pod, and create a service which is called API1, and the image will be the echo server. Echo server is a specific container that echoes the information about the environment. And I am saying that, okay, make this application work on AT-AT, and this will have a specific label, which is app is equal to API1. Okay. So API1 is created, and let's expose this service to the outside, because by default it is not reachable. When you say, okay, by the way, actually you need to use kubectl, but I have an alias for the kubectl, pod plus 3c. I am saying that get me the pods and the services. Here, as you can see, there is only one pod, and then there is only one service. This is not ours, okay? This is the system service. In same way, I will create another service and expose that. Okay. And let me create the third one, not this one. This is the third service. Okay. Now I have 3 pods, and then I have 3 services. There is no problem there. And what is next here? So I need to create a set of rules in order to let my system to route traffic into the cluster, okay? First of all, I just wanted to show you the exact rule here. Let's say that Ingress and vi microservice. Okay. Here, I will say that this one. When you have a look at here, I am saying that, okay, for like every other Kubernetes object, here you will see the API version. It is v1 version 1 beta 1, and my kind is Ingress. I am defining an Ingress specification here. As you can see, I am providing my name, Ingress microservice, and you can use several kind of annotations here. If I want to show you here, let me provide you an example, or provide you some information about these annotations. So annotations help you to configure something within your system. So here we are dealing with the Ingress, so you can do lots of things about these Ingress definitions. For example, if you are using microservice pool, you will have that. For example, if you are using a one-page application, you may need to allow some cross-origin request sharing properties here. Also, you may need to set up some sticky sessions properties. There are lots of things here. You may have a look at this URL and then configure your system by using these annotations. So here in the spec session, it is very simple. My rules are, I have 2 rules, okay? So if the request comes with this host name, API1 myapp.io or API1 myapp.io, and if you try to make a request to a route path, okay, this request will be automatically routed or proxied to the API1 service name, which we already created, and it will try to make requests to this specific port. Okay. Also, if you make a request by using this host name, and if your context path is the route path, these will be proxied to the API2 and the port here. So you may not need to provide these host names. Also, you can provide different kind of paths here. There is only one because of the simplicity, but you can provide several paths here in order to route your traffic to different services. But this is the very basic configuration of the Ingress. And then, as you can see here, backend, if your request does not match any of these rules, your request will be automatically proxied to this default backend, okay? Currently, I have no default backend, but you may start some Nginx instance on port 80. So your traffic goes here by default if there is no match with these rules. So let me apply this. By the way, I just wanted to divide my screen into 2. So Okay, so here I just wanted to show you the logs. Okay, here are logs. These are logs. So I just wanted to apply this one, microservice ingress. Okay, so our ingress is created here. And then, as you can see, the Ingress backend successfully reloaded. So what is next here? We will do this. First of all, in order to use the host names as specified in the Ingress rule, okay, I will get the IP address first. So when you say minikube IP, you will get the default IP address here. So I will create an entry here. Okay. So I already have an entry here. So this IP can be resolved by using those two host names. So there will be no problem there. Let me make a request to these endpoints. So API 1, my app IO. As you can see, this request will automatically go proxy to this host name. As you can see, this is the API 1. This is the host name of the specific pod here. What else here? Okay, you can see the some informations here related to this request. In same way, if you make a request to API 2, you will see that the request automatically proxy to this second service. This is the very basic demo of the Ingress, how we can use the Ingress, but you can think this Ingress architecture like an API gateway. So this was for the request traffic control, but you can also add some features by using the annotations that I already mentioned here, okay? So we can continue with the network policy, I think. But in order to use network policy, I will use Google Kubernetes engine in order to do that, because it will be very difficult to apply that in Minikube. Normally, in order to create a cluster, Kubernetes cluster within the Google Cloud console, you can use this command, gcloud container clusters create, and provide your name, cluster name. I have specified a zone. You can specify your own zone, whatever you want. And then I am saying that, okay, enable the network policy here. If you do not do this, your network policies will not be work, okay? So I need to switch to the Google Cloud Kubernetes cluster. So let me do this. So as you can see, we were in the Minikube context. So I just wanted to change my context to the my cluster, which is currently on the Google Kubernetes engine, okay? So when I said get node, this time we will see the cluster members in the Google Kubernetes engine. Okay, cool. So let me delete lots of things here. So, okay. This API, 1, 2, 3, okay. All of these services are already created here, services. And we have pods and services, I think. Okay, we have 3 pods, 3 services here. I don't want to repeat the same procedure here because they are already here. So when you say get po for the all namespaces, let me widen this window here. Okay. As you can see here, there is Calico type, Calico network provider here because I provided the enable network policies. So you can use any kind of supported network provider there, but I am using Calico by default. So the Calico is enabled on the master, and also since I have 3 members here, as you can see, there is 1 per the cluster member. Okay. Okay. So we can continue with our demo about the network policies. Okay. So let me test this system first. So I will create 3 windows here. Okay. Same here. Okay, we are cool. First of all, let me show you that everything is working as expected here. So when I say, okay, get po, I just wanted to connect all of the instances one by one. So I am saying that, okay, interactively connect this pod, the first API, and then as an entry point, use bin sh. Okay. So I am inside the first pod. In same way, I am using the second pod here. Okay. And the third one. Let me check the connection first. For example, I'm able to connect to the second instance. Okay, there is no problem here. I'm able to connect to API 2 from API 1. There is no problem there. So what else? Connecting to the third API. So there is no problem there. When you check the others, you will see that, okay, the connection works vice versa. API 3, for example, 8080. Okay, no problem there. But as you can see, by default, there is no restriction about the intercommunication between the pods. I will create my first rule for the Ingress one, okay? And that will be, let's say that okay. This is my first network policy. As you can see, again, there is API version, there is a kind. I'm saying that I will define a network policy here. And then I am providing a name here. Let's say this one is Ingress. Okay. And here, first one, you need to say the main responsible here. So this rule is for the pods that has a label app is equal to API 1. Okay. So as you may already remember, we have provided lots of labels here. First, where is it? here, let me show you. Get poll. And when you describe the first poll, you will see that there is a label for the first API. App is equal to API 1. Okay. I am saying that this rule, ingress rule, will be for the API 1. And then policy type will be ingress. And also this can be egress at the same time. And I am saying that there will be only connection to this pod API 1 from the pod that has an API 3. Okay, this means API 3 can only connect to API 1, so there will be no connection from API 2 to API 1. Okay, but this rule for only incoming connection to the API 1, not the API 2 or API 3. Let me save this one and apply. Okay, when you say get policy, network policy. Okay, there is only one network policy, and this is for the first API. Okay, so here, let me try to connect API 1 from the API 2, okay? Our rule was, okay, only API 3 can connect to API 1, okay. Let me try to connect from API 2, API 1. As you can see, there is no connection. Okay, this will be timed out. But when you have a request from here, API 1, AD, okay, there is no problem. Let me change this one from API 3 to API 2 and see what happens. Okay, the rule is configured. And when you try to connect to API 1 from 2, you will see that the connection is successful. But when you try to API 1 from the API 3, there will be no connection, okay? By the way, for example, a couple of years ago, in order to set up such a thing, you need to configure lots of firewall rules or etc., something like that. But this feature is very powerful, and you can change any kind of rules on the fly, okay? This is a powerful property for the system. So we have defined our ingress rule, but what about the egress? Let me provide you an egress rule in order to restrict your connection, because on some cases you may need to restrict your pod in a way that it will not be able to connect to outside system. Okay, this time it will be egress API 1. Okay, so here again, I am saying that I will define a network policy, and then this time our hero will be API 1. So this egress rule will be valid for only the API 1. Okay, API 1 will be restricted for outgoing connections. I am saying here that policy type will be egress, and then this API 1 will be able to connect to API 3 only, but there will be no other connection types. Let me apply this one. Okay. So API 1 will be able to connect API 3, but API 1 will not be able to connect API 2, or will not be connect to google.com. Let me try to connect to API 3. So I am not able to connect. What happens here? Let me double check the, okay. I should be able to connect from API 1 to API 3, but why I'm not able to connect to API 3? Do you have any opinion on this? Why I am not able to connect API 3? Let me give you a clue on this. I am using host names here, but this host name should be converted to a physical API address, right? In order to connect to an exact destination. So in order to convert this host name to an IP address, you need to contact to a DNS server, right? But this rule will restrict your pod to connect to the DNS server. And this is the reason why we are not able to connect to this system, because we are blocked on resolution side by contacting to the DNS server. So in order to do that, I need to provide an exception here in order to connect to our internal DNS server, because you may already know all the connections, all the service discovery done by using this strategy. Let me do this in order to be sure. So here I am saying that, okay, the egress rule, by using this egress rule, I will be able to connect to this port via UDP and TCP. This is for DNS resolution part. And then after that, I will be able to connect my API 3. Let me reapply this one and then try again. As you can see, it is able to connect to API 3, but when you try to connect API 2, you will be blocked again. Yeah, this is very simple. This time I will delete all the network policies. So, okay, I have no, as you can see, the connection automatically established once I delete this network policy rule here. So this time I will apply some more general rules here. For example, I want to deny all the ingress connections here first. Deny all ingress. Here I am saying that, okay, this will be default deny. And let me say that default deny ingress. And then pod selector is something like more general. This is the, you can think this is the wildcard. So this ingress, there will be no ingress to the all of the pods, okay? Deny all ingress. So let me as you can see, there is no connection. In same way, there will be no connection here too. Okay. So this is for denying all the ingress connection to the pods. Let me create another one. This time allow all Ingress. In same way, there is no, it is the wildcard, and then there will be, from any kind of location, the connection can be successfully established to these wildcard pods. Okay, as you can see, this rule overrided all the definitions, so you can successfully connect to the outside system. As you can see, there is connection by default. So what about I just wanted to deny all the outgoing connection for every pod? It is very simple. Just create a rule, deny all egress YAML. And here I am saying that default deny egress. I am saying that, okay, for all the pods, there will be no outgoing connection to anywhere because there is no egress definition, egress field here. Apply deny all egress. When I say this, and when you check this part, API to 8080, okay, there is no connection. So you can also check this one, curl HTTPS. There is no Google connection to, there is no connection to anywhere. So this is the sample deny all egress. And finally, I just wanted to show you allow all the egress connections. So this time, allow all egress YAML. And in the same way, you can see that pod selector is wildcard, so this will be applied to all of the pods, and then there will be outgoing connection to every place. And this will be a egress policy type. Let me apply this one again. Allow all egress. Okay, curl. Okay, there is a connection, and also curl HTTP API 1 8080. Okay, there is no problem here too. So this is the end of the demo. I hope you have learned a couple of things about Ingress and the network policies. By the way, you will see Ingress term several times. If you use this Kubernetes inside your company, there will be lots of Ingress things. But network policies is a very new thing. And in order to create such an architecture, you need to define your network policies first on a sheet or on a design board, something like that. And then you need to apply your network policies to your Kubernetes architecture, okay? And do you have any kind of question about Ingress or network policies? By the way, we were trying to do a webinar per week, but next week I will be on booking.com in order to make a talk on the Kubernetes and microservices. So I will not be able to make a webinar on next week and the following week. So after 2 weeks, I will be here with the new fashion topics. But if you have any volunteer friends, or if you wanna be a volunteer in order to make a webinar on any kind of topics, it can be about DevOps, it can be about software. Feel free to contact me in order to prepare this webinar. And one reminder here, we have a community channel on Slack, so you can easily access here and then ask any kind of question, because we are trying to be very active on here in order to notify people about our webinars, about our physical events on UK, or on another locations. Feel free to join here. Let me provide you the link. Yeah, here. Okay, on the chat, I provide you the URL, and also let me write down here. Okay, this is our URL, Kloya community on the bit.ly. And that's all. If you have no other question, we can finish here. Thank you all for coming to this session, and see you on the next webinars. Have a nice day. Have a good night, and bye.